Hi, my name is Corvette, and I'll be talking to you about the NASA aircraft and which material they should use. So, when we got our thing, we had four groups. One of the groups was polymers. In the polymer group, we looked at properties such as hardness, tensile strength, elasticity, and melting point. In our client, we wanted a high melting point and high hardness, a middle tensile strength, and we didn't really care what that elasticity was. So the materials in the polymer groups were polyphenylene, polyurethane, and acrylic resin. And so for hardness, the hardness ranged from not applicable because it was not tested to 7, and tensile strength ranged from 50 to 152. Elasticity ranged from 0.05 to 5.5, and melting point ranged from 110 to 238. So since the hardness and melting point was not high and we wanted it higher, we could not use this material in order to build the aircraft so that the material would not melt when coming back to Earth. Another group was metals. In the metals group, it consists of steel, platinum, aluminum alloy, and tungsten alloy. The hardness for metals ranged from 90 to 798, 171 to 370, 80 to 220, and 674 to 1768. Now this is a wide range of varieties in the metals group, and we really considered using a metal to use as our product, and we decided that it was not the best candidate, however, because in a group later on that we're going to look at, it has higher hardness and tensile and melting point than this group, and so that really pushed over the other group over this group. Another group was woods and fibers, and in the woods and fibers, the materials that we were looking at were birch and white pine, which are two types of trees. The hardness for these were not applicable because they never tested the hardness, and the melting point was also not applicable to these two. But the tensile strength was 1.8 to 6.65, and elasticity was 1.8 to 6.65. Oh no, the elasticity was 10.1 to 15. Now, since the hardness and melting point was not applicable, we already crossed that out of the group because we needed to know the hardness and melting point in order to create the best aircraft and use the best material in our aircraft. And our last group that we tested were ceramics. This group of ceramics we decided to use as one of the materials to build the aircraft. So the materials that there were to choose from were quartz, alumina, and silicon carbide. And in the ceramics group, the hardness was 1,023 to 2,894. The tensile strength was 70 to 300. The elasticity was from 74 to 370, and the melting point was 1,670 to 2,700. Now this had both the highest hardness and highest melting point, which we wanted for our client in order for them to have the best material possible. And the tensile strength was in the middle, so it wasn't like over high, too big, or it wasn't too small. And the elasticity was also just right. We didn't really mind what it was because we didn't really need it. So the material we decided to choose for the NASA aircraft was silicon carbide. Bang, bang, bang. And so for silicon carbide, it actually consists of the highest hardness and highest melting point. The hardness was 2,894, and the melting point was 2,700. So these two factors alone really distinguished it from the other ceramics. And also the tensile strength was 124, which isn't bad because it's like in middle range. It's not that high, but it's not that low. And the elasticity was 370. This was the highest, but it didn't factor into the decision of what we wanted to use as a material for our NASA product. And so what really distinguished this silicon carbide was the hardness and melting point used, because it was the highest. And for NASA, for their aircraft to be able to go back into Earth, it needs to have a high melting point and it needs to have a high hardness, so the material doesn't break and it doesn't melt when coming back to Earth, because a lot of heat energy is given off when going back to Earth when in a rocket. So in the silicon carbide model, like this one shows like that it's hard and it's sturdy, and that it's really like it's sturdy and stuff. And so this one, these two are kind of like showing like the models, and like it's showing like how its melting point is pretty high, and that like it's just like sturdy and will not break. So in conclusion, we decided that NASA should use silicon carbide in order to create their rocket ships, so the rocket ships will not break when coming back to Earth, and so that the material will not melt when coming back to Earth. Thank you, NASA.